Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. So my name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss the topic other complex gates. So what are the other complex gates? Let us see. Okay. What are the other complex gates? You can see the other complex gates. Complex gates. Complex gates are more than two inputs. Okay, so logic gates. So other complex gates, more than two input logic gates, more than two input. So more than two inputs. More than two inputs are called complex gates. More than two inputs. More than two inputs are called more than two inputs are called complex gates. Okay, complex gates. So complex gates are designed by the logic. Complex gates are designed by complex gates are designed by complex gates are designed by logic. Designed by logic and or logic. Okay, logic and or logic and logic and logic. Okay, and logic or logic and logic or logic. Okay, and logic and or logic. So we can design this Cmos and Nmos. So design we can design by Cmos. We can design by Cmos or Nmos design style. Cmos or Nmos design style. Cmos or Nmos design style. Okay, design style. Right. Let us see this one. Let us see this one. The first one, let me go for example. So example complex design. Examples are, first one is a complex design. For example, A into B plus C into D plus E complement. Okay, complement. So this is example 1. Let us see example 2. Example 2 is D plus A into B plus C. So designed by this it is a complex design. You see how many inputs are here? A, B, C, D, E. 1, 2, 3, 4, 5. So 5 inputs are here. Right? Here also 1, 2, 3, 4. Okay. So 4 inputs are here. So we can design by this. Design by, okay, design by CMOS. Design by CMOS style. Okay. We can design by CMOS style. And also we can draw the stick diagram and draw stick diagram and draw CMOS design style and draw stick diagram. Okay, we can also draw the stick diagrams. Okay, stick diagrams. So let us see the first example. Okay, let us see the first example. So what is example 1? Example 1 is AB plus C into D plus E complement. Okay, so this is example 1. Let us draw this one. It is a complex design gate because more than two inputs are here. Okay, two inputs, it is more than two inputs. 1, 2, 3, 4, 5. 5 inputs are here. Let us draw the, first we draw the Nmos. First draw the Nmos. First draw Nmos. So first draw Nmos circuit, Nmos logic. First draw Nmos logic. Nmos logic. Then complement of Nmos is PMOS. Then complement of complement of Nmos, complement of Nmos logic, complement of Nmos logic. Okay, so that is PMOS logic, PMOS logic, PMOS logic. Okay, so here in Nmos, in Nmos, in Nmos, okay, in Nmos, in Nmos design, in Nmos design, Nmos, this is pull down. So this is in CMOS, in CMOS. This is, we can design in CMOS logic, in CMOS style. Okay, in CMOS style. CMOS style means both NMOS plus PMOS, NMOS plus PMOS, NMOS and PMOS, both styles we can draw. So in NMOS, so and the logic in NMOS, let me this one in NMOS, and the logic. So and the logic NMOS are NMOS in NMOS and the logic transistors are series. In and logic NMOS transistors are series, and logic NMOS transistors are series. Okay, NMOS and logic NMOS transistors are NMOS transistors in NMOS design. In NMOS design and logic NMOS transistors are series. NMOS transistors are series. Okay, OR logic, OR logic NMOS transistors are parallel. NMOS transistors are parallel. NMOS NMOS transistors are parallel. Okay, NMOS transistors are parallel. Series parallel. You see here, what is the two logics are here? You see this one. So AB, this is a series. Okay, and this is a parallel. And C is in series with D plus E. So D plus E are parallel. Okay, so and logic, OR logic, and logic and OR logic. You see how many logics are? Two logics are over here. So and logic plus OR logic, and first product term is and logic, plus the remaining three are OR logic, and in these three C is and logic with a D plus E. Right? This is about the given complex gate representation, Boolean expression. Okay, complement is nothing but pull up, pull down. It is a complement. Okay, so complement. PMOS is a complement. PMOS is the complement of NMOS. PMOS is the complement of NMOS. Complement of NMOS. This is what happened. So let us see the designing. Right. So first you can draw A plus B. A and B are series. A and B are series. Because and logic is here. A and B are series. You see this one. A and C. Any complex gate is given. You can see the logic A in NMOS. So CMOS design means NMOS, pull down NMOS, complement is PMOS. So A and B are series. You see A and B are series. Right? So what is the logic here? A plus, okay, let me take here. A into, what is this? AB plus C into D plus E complement. Let's see this one. Okay, you see A and B are we drawn. Okay, NMOS transistor series, and logic means series. Right? So C is here. What is C? C is parallel. The second term, total the second term, parallel. Okay, C is parallel. You see, C is parallel. So keen observation, what I am writing. If any logic is given, you can draw simply you can draw. C is parallel. Right? C is parallel. Now, what about D plus E? And there is an AND logic. So both the C, D, E are parallel with AB, and in this C, the second term, this is a second term. Okay, let us take this is first term and this is a second term. Right? So first is AB series, So second term completely it is parallel, and C is AND logic with the D plus E. D and E are parallel, ma. D and E are parallel. You see this one. D and E are parallel. Okay, D and E are parallel, and it is in series with C and parallel with AB. Parallel with AB. This is what the logic. This is what the logic of Nmos, right? So D and E. You see, AB is series. Okay, the second is completely parallel. Okay, R logic, and in R, so C is in series with the D plus E. D and E are parallel. So plus means OR logic. So plus means OR logic. So AND means product term. AND means series logic. Okay. Plus means transistors are parallel. So plus symbol means parallel transistors. Remember this one. Parallel Nmos. In Nmos, parallel Nmos, right? And logic, if it is and logic is here, so what is called, this is and, okay, dot, and means so series Nmos, right? So then complement is a PMOS transistor, right? So AB here series, now AB is parallel. Okay, so let me take this. AB are parallel. So series is here. Now AB are parallel. Okay, AB are parallel. This is a PMOS. AB are parallel. Okay, AB are parallel. This is the output over here. So AB are parallel. A and B are parallel. Complement. So PMOS bubble and bubble over here. So AB are parallel, right? ABR series, the complemented logic ABR series, ABR parallel in CMOS, right? C is here. How it will be to this AB? It is parallel. So this is first term, this is second term, parallel. Now it will be C is series. C is in series. Okay, C is in series with this parallel. Okay, so here it is parallel. Now it will be series. C is in series, right? C is in series. Okay, so like you can take, okay, C is in series. And what about this D plus E? D plus E is parallel here, in series with C in pull down, but here it will be parallel. Okay, so let me take this one. How it will be? D and E are series here. D and E are series here. Okay, so this is what the representation. This is what the representation. You can see this one. Okay, so above one is, this is a PMOS transistor. C is in series, and how this will be? Can also take like this one. It is series representation. You can also represent this one. It is series. So here it is parallel. First term, second term parallel. So here ABR series, complement ABR parallel. Okay, parallel. And C and D plus C parallel. But here it is series. C is in series, and D and E are parallel. Here it is series. Okay, right? You can go through and practice this one. So D and E, right? So PMOS transistor, VDD, okay, VDD, VSS, and Vout. So Vout, VDD, VSS, Vout for the given logic, the complex gate representation. It is a so complex CMOS design, complex complex CMOS design, complex CMOS design, CMOS gate, complex CMOS gate, complex CMOS gate ma. So this is complex CMOS gate design for the given logic, AB plus C into D plus E complement. So you see this one, series and parallel, and in series with the parallel of D plus E. Then what is the complement? Complement is nothing but pull up transistor and pull down transistor. Pull up, pull down means the complement is given. pull up pull down is a complement. Okay, pull up pull down is a complement, right? Like if you see a PMOS and NMOS, PMOS and NMOS, okay, then what is the output is output of the CMOS? This is a CMOS inverter. V in we are applying, okay, and this is V out. A is the input, A is the input, output is A complement, output is A complement, A complement, the complemented output. So output here is depend on the pull down NMOS, then the complement, right? CMOS is complement of NMOS transistor. CMOS is complement of NMOS transistor, right? So how can we design NMOS? Let me draw this one in Nmos. Okay, let me draw this in Nmos so you can understand easily. So in Nmos means same. So you can draw this one in Nmos. A and B are series. A and B are series. Okay, C is parallel. Okay, C is parallel, right? C is parallel, and D and E are in series with C and parallel with AB. Okay, right? So this is what in the design. This is what in the design. NMOS, and above one is depletion mode transistor. Depletion mode transistor is depletion mode transistor is always constant, which will not change. Which will not change, ma. Okay, you can see this one. This is NMOS design. So VDD, right? VDD and VSS. Okay, AB, C, D and E. D and E. You see, the logic output is, so the V out is equal to the logic. By seeing this logic, we can draw here. Okay, we can write here according to the circuit diagram. We can write the logic. You see, A and B are series here. We can write AB series. Okay, C is parallel plus C and DE are parallel. So this is series and this is series. So both are in parallel. So C is again in series with D plus E, in series with D plus E, and complement. So complement is because of the pull up and pull down. Remember this, pull up and pull down. This is pull up transistor, this is pull up transistor, and total this one is a pull down transistor representation. So it is a NMOS, complex NMOS design. So this is complex NMOS gate. We call it is complex NMOS gate. Complex NMOS gate design. Okay, complex NMOS gate design, ma. Okay, you can remember this, and logic or logic. So if it is NMOS design, so depletion is always constant, which will not change. So changes in the pull down transistor, enhancement region. The logic is depend on this enhancement region, series and logic, parallel or logic. Okay, so you see this one. So replacing this depletion mode transistor, with PMOS is called Cmos design. So PMOS and NMOS. Okay, PMOS and NMOS. So PMOS is complement of NMOS. Okay, complement of NMOS. So actually the original is NMOS inverter only, NMOS design only, depletion mode transistor only. What is the changes? Replacing, because of the constant current flow through this one, and replacing this with the pull up is PMOS transistor. So it is a CMOS complementary gate. Okay, right. Let us see the let us see the second. Let us see the stick diagram for this. Okay, so that and stick diagram means let me draw here. So what is the stick diagram of this one? So VDD means blue. So VDD VSS are blue, ma. VDD VSS are blue, right? So what happens this one? So red over. What happens this one? Red over green. Okay. So this is a green color. So this is also green color. This is one green. So green and green over here. Okay. So we can connect this one with a green. Okay, and we may also connect from here to here, green, right? So what is the red? So red is here, the short circuited polysilicon. Okay, so polysilicon over here, polysilicon over here, polysilicon over here, polysilicon over here, polysilicon over here. You see, this is about stick diagram representation, stick diagram representation. Okay, so and yellow dotted line is nothing but a depletion mode transistor. We already discussed the stick diagrams of Nmos design and Cmos design. So this is a VDD. Okay, this is VDD and VSS. VDD VSS. So blue color, right? This is a blue color representation. Blue color, ma. So blue color, okay, and red color, blue color and red color and green. So this is a green color. Okay, green color representation. So stick diagram for the given logic, right? And let me tell you this. So this is A and this is B. This is C, D and E. D and E. So for the given logic, that we have space. Okay, let me draw this one in CMOS design style. So CMOS design style, we have the stick diagram for this stick diagram, CMOS stick diagram. Okay, VDD VSS are here. VDD VSS are here. So what happens? Green color over here, green color over here, green color over here. So both are in series. Okay, you can also take this one. Okay, and polysilicons, how many polysilicons? 1 2 3 4 and 5. So AB, right? So this is AB, A, B, C, D and E. Okay, stick diagrams. So complement is red over yellow. Okay, red over yellow, red over green. So red over yellow means so we can take here. Okay, A and B are here. Okay, A and B are here, right? From here to here we can take the metal, right? Another thing, here again yellow is here, red over yellow. Okay, red over yellow. Otherwise we can take the interconnection by using the metal. Okay, the red over here. Okay, A and B, C, D and E, ma. Okay, so let me write this. So A, this is B terminal, this is C terminal, D terminal and E terminal. Where the interconnecting point we can take the black contact. Okay, interconnecting point. These are the interconnecting point. Okay, interconnecting point, black contact. Okay, so here also interconnecting point, one interconnecting point over here. So this is what we can take output signal. Okay, this is also output signal, right? Output terminal. This is output terminal, right? This is CMOS stick diagram, CMOS design stick diagram. Okay, CMOS design stick diagram, stick diagram given logic. Okay, given logic, right? Now let me see the another example. Okay, let me see the another example. So we can say this is a V out VDD. We can take it is a VDD, VSS, and this is V out. Okay, so previously here also some black contact is there where the interconnection point here also interconnection point, right? Here interconnection point is here. So this is about a stick diagram. Let me write here. This is a stick diagram of Nmos, stick diagram of Nmos logic. This is Nmos logic. Okay, now let us see the second example. What is the second example is given? Second example is given in previous. Okay, so it is D plus A into B plus C. Okay, right? D plus A into B plus C. Similarly, we can draw same thing. Okay, so D is parallel with the ABC, right? Let me draw this NMOS, then we go for this CMOS design. Okay, so you can see this one. So this is a depletion mode transistor, pull up transistor. It will no change. Now let us see this one. D is a simple single NMOS transistor, and remaining second part is A is parallel. Okay, A is parallel and it is in series with the B plus C. It is in series with the B plus C. You see this one. You see the logic, how it will be designed by a transistor level representation for the given logic. It is a transistor level representation for the given logic. In NMOS design, so it is a complex design gate. Complex design gate. Okay. So this is VDD and VSS. Okay. So what are the inputs are here? This is D. Okay. And the input gate, this is A. Okay. And A. Okay, and B and C. Okay, B and C. Now the depletion mode transistor is short circuited here, short circuited here. Okay, short circuited here. Okay, we can take this as a output. Okay, from here we can take is as a output. Now, so it is pull up transistor. This is pull up transistor. Pull up transistor, completely these are the pull down representation. Output is, what is the output here? From the logic D. Okay, D and plus A into B plus C complement. It's a complex design gate representation, right? Let's see the Cmos design style. So it is Nmos design. Okay, so this is Nmos design. Nmos design. Nmos design for the given logic. So any gate, any logic representation we can draw simply. Okay. Now, now it is a CMOS. CMOS means PMOS and NMOS. Same NMOS. PMOS is a complement. So D. Okay. D is here. D is here. And A is parallel. A is parallel. Okay. A is parallel. Now, what happens this one? B and C are parallel. B and C are parallel. It is in series with A. Now D is here parallel. Now D is in series. D is in series. Right. D is in series. Okay. D is in series. C is A is parallel. But here A is series. A is series. Okay. We can take A is series. And B plus C are parallel. Here it is series. So B and C. B and C. One more transistor is here. Okay, so B and C are series. B and C are series, right? So this is what the representation, and bubble is here. PMOS means bubble representation. Okay, this is a bubble representation. Bubble representation. So this is D. A is parallel and okay, parallel. A and BC are parallel and A is in series with B plus C. Okay, so this is D and A is in series and B and C are parallel. So this one is VDD, right? VSS and V out. Okay, we can also draw the stick diagram for this. Okay, you can also draw the stick diagram for this. So it is a CMOS gate, CMOS gate. So CMOS design. Cmos design. Okay, Cmos design. So this is Cmos design. Okay, for the given logic. Let me draw the stick diagram. We are drawn here. Okay. Let me draw before this. Okay, VDD, VSS, VDD, VSS are blue color. Okay, and here green over here. Okay, green over here, red over green. So green over here, two greens are parallel. Two greens are parallel, which can be connected over here. We can also connect the same thing. Also, we can connect over here. Okay, then red color. So here red color is short circuited red color. Okay, and how many polysilicons gate? 1, 2, 3, and 4. Okay, so what are those? A or D? This is D, A, B, and C. Okay, so depletion mode transistor, yellow dotted line. So red over green with yellow dotted line. Yellow dotted line. Okay, yellow dotted line representation. Yellow dotted line. Okay, right. So let me write down this. What is VDD? This is VDD. Okay, this is VSS. And from here we can take the V output. This is we can take V out directly. We can take this here V out. Okay, for a given logic. So red over green. What are the colors here? Red. Okay. So this is yellow. Okay. And this is blue. Okay. Blue. And red over green. Red over green. Green color is here. Again, it is a green color is here. End diffusion. Green color is end diffusion. So what are the contacts? You can see this is a contact. Contact cut. Okay. Contact interconnecting of two layers. So metal and this end diffusion, metal and end diffusion. Green color, end diffusion means representation green color. Okay. Now, so let us see the stick diagram over here for the Cmos design. Cmos design stick diagram, same thing, ma. Okay. VDD, VSS are blue color. So here, red over yellow, red over yellow, red over yellow. Okay. So we can interconnect from here, one transistor over here. And then the green color. Okay, then the green color is here, then the green color is here. Okay, you see this one, right? Okay, you see this one. Okay, now we can take the yellow directly from here, so red color. So how many polysilicons here? A, B, C and D. Here also D, A, B and C. Okay, now the interconnecting point, where the interconnecting point from here. Okay, interconnecting from point from here. Okay, right, from here to the metal, diffusion to metal, diffusion to metal. Okay, so directly we can connect it over here, right? From here to we can take output metal, from here to we can take output, right? It is a metal, blue color representation, blue color. Okay, where interconnecting point is, we can take this one, right? Contact point, black color. Okay, black representation, black representation. Let me represent this all. Okay, so this is VDD, VDD, VSS. So what is input? D, A, B and C. Okay, D, and this is A, B and C. So it is a complex design gates, Nmos and PMOS, it is CMOS, stick diagram. So this is called a stick diagram. Okay, stick diagrams, stick diagram for a given logic and circuit diagram. According to circuit diagram, we can draw the stick diagram. Okay, CMOS design and NMOS design for the given logic. Complex gates. Okay, complex gates are more than two inputs are here. So designed by CMOS and NMOS. Okay, so thank you. Please subscribe our channel, inform to your friends, like and okay, learn the subject. Thank you.